This was my drone project for ECE 216. And the project instructions were to design a drone capable of delivering a cargo package carrying emergency relief supplies to areas in need. And the drone needed to consist of at least 10 unique parts and have a mechanical drivetrain with functional motion, as well as a mechanical mechanism to secure the package in transit. The drone needed to have at least one motor, power source, charging method, and microcontroller. And this picture at the bottom is of the relief package that the drone needed to be able to transport. So the first thing I did was go into SolidWorks and kind of measure this package, learn the dimensions to try and figure out what my drone needed to look like and what kind of size it needed to be before even starting the rest of the process. Next up, in the first step of the Imagine step, I created a mind map. And I created a mind map with the goal of brainstorming project ideas and starting to think about how I was going to approach the rest of the project. As you can see in the bottom right down here, this was the mind map that I created, and it has different modes of transport, different power sources, design ideas, and charging methods, and some below average drawings next to them. And this mind map kind of allowed me to look at these different ideas, see how I could put them together into one design, see how they might mesh well together, if one design might work well for a different charging method but not be good for a different mode of transport. I can cancel that out and move further with another design that I wanted. And after creating the mind map, I was able to get a clear understanding of where I wanted to take my project and allow me to begin the next step of sketching out design ideas. During the sketching process, I was able to begin designing the layout of the drone and estimate the number of parts. So these were my 3 original drone sketches. And as you can see, this one on the left is kind of a quadcopter. This one in the middle is kind of an on-the-land treaded vehicle type of thing. And then my design 3 was meant to be kind of a boat on the water. And I wanted to try a different design for each mode of transport. So design 1 was air, design 2 was land, and design 3 was water. And you also added the different number of parts and the estimated number of costs, and just kind of get a basic understanding of where I might want to go down with my different ideas. During the selection process, I used a decision matrix to determine which design was the best for my project. The criteria I used in this decision matrix was cost, which had a 30% weight, motion, which had a 20% weight, sustainability, which also had a 20% weight, theme, also 20% weight, and then creativity with 10% weight. And you can see that selection or design matrix in the bottom right. And ultimately, design 1 ended up winning, which was the quadcopter design. These were the parts for my project. My project contained 12 individual parts, with the main parts including the base, the rotor blades, the solar panel, the battery, etc. So this was the base in the bottom left. This is kind of where everything was stemmed off of. This is the center of my part. Everything kind of connected to this part. And I also think it looks pretty visually pleasing with the different fillets I added to it, so it's not super sharp. This is the rotor blades part. This is probably the hardest part of my whole project. I'd look up different videos online to kind of get some inspiration of how I wanted to build these, but I think they turned out pretty good in the end. And then this was my solar panel. Same thing, I had to look up some different inspiration online and then kind of recreate it the way I could on SolidWorks with the skills I do have. I originally wanted to put kind of a glass film over the top, like a regular solar panel, but I couldn't really figure out how to make it look good, so I ended up kind of just scratching that idea. But I still think it looks pretty good. And then this is my assembly all together. In my assembly, I used multiple different types of mates to put all my parts together into an assembly, such as coincidence, distance, parallel, and angle mate. I also used smart fasteners to add the countersunk screws to hold my parts together. So this is what it looks like in the end. I also added the material to all of it, so this is all ABS plastic. And you can see in different areas there's some screws and how all the parts kind of fit together, and the different parts with the base and the rotor blades. So for the motion of my assembly, I used a belt to move all the rotor blades simultaneously using one motor. You can see in the bottom left, all the parts are connected by belts, and they're all spinning with one motion from one motor. And then for my mechanical mate, I used this kind of hook thing to hook onto the package, and then it rotates back into the part to release the package. And then for my drawings, you can see the bill of materials in the bottom right, as well as all my exploded drawings in the top right. My drone was completely made out of ABS plastic with the purpose of keeping the weight low, but also being sturdy enough to carry the package. I wanted to keep the weight low because obviously my drone does need to fly, and I will also be picking up a heavy package, so I didn't want to make my drone too heavy, which might make things difficult to actually get off the ground. And so the total weight of the drone ended up just being under 15 pounds. In conclusion, I thought this project forced me to push myself on my SolidWorks skills. I had to do a lot of looking things up, had to go back through the different lessons to try to figure out how to create my project the way I thought it deserved the experience of. I gained a lot of experience in both the creation of the part as well as the assembly of those parts. This is my first time building an assembly and all the parts with the goal of putting it all together into one assembly. So it was something I had to get used to, something I had to learn how to do. I think in the future I could probably organize it a little better, but I think it worked out pretty well this time. I enjoyed getting to show some creativity in my designs, as well as working out how to bring that creativity to life in an applicable situation. So yeah, I really wanted to make my drone look cool, look good, not look super boxy or like it was not too creative or anything. So I wanted to make it look good and like there was actually thought process put into it, which I think I did. One mistake I made was creating the design of the drone, then making that design functional. So what I did is I made the design in my head and then tried to figure out how to make it functional afterwards. But if I were to create another project, the first thing I would do is make the drone mechanically functional and then figure out a cool design on top of that already so it would fit together all in the end. Thank you.